in light of the previous discussion on integration, the introduction to the topic of integration, now let us go forth and look at what integration actually is from a very simple standpoint or very simple context, that the integration is the reverse process of differentiation. Integration is a lot more than that, but of course it helps our understanding of integration if we know how to do the integration process mathematically first, and then go into the depths of the geometrical as well as the mathematical meaning of integration. So let us begin our journey into this beautiful world of integration by a simple definition. Let small f and capital F be two functions such that the derivative with respect to x of small fx plus a constant c equals capital Fx. Then we say that when we perform a certain operation, a certain mathematical operation on capital Fx such that we get back the original function small fx plus c, which was differentiated in the first place, then we call this function small fx plus c as the integral or the antiderivative of capital Fx plus c. So this operation, this mathematical operation that was performed on capital Fx is called the integration of capital Fx. So therefore we say that this is the integral or the antiderivative of fx with respect to x. And so this dx denotes with respect to what variable the integration is getting performed. So therefore, from this definition, you can see that when a function is differentiated and then integrated again, you get back the same function. So suppose here the function small fx plus c was differentiated and you got capital Fx. Capital Fx was integrated and you got back small fx plus c. So this c is the constant of integration. This is just put there to be safe, because that is the more mathematical thorough way to put it, because we know that the derivative of the c is going to be 0 anyways. So what if fx is accompanied by a 0? Whether it's a positive constant or a negative constant, the derivative of this constant is going to be 0. So why not put it as capital Fx plus c? Because that is the function to be differentiated in order to get back the function which is inside the integral sign, capital Fx. And moreover, talking in terms of technical terminology, the function which is getting integrated is called the integrand. Now, in light of this definition, it's obvious to ask the question whether we have some standard integration formulas just the way we have some differentiation formulas. The answer is yes, we do have standard integrals, what we call standard integrals, which are basically derived from by reverse engineering the standard derivatives formulas. Want to see how they are? Let's go ahead.